So now that we've looked at antiderivatives, what we're going to do is make a little cheat sheet, because it kind of helps to go back and forth between the two, derivative, antiderivative. So we're going to do derivatives first, and then integrals down here, and then you have a cheat sheet to look at for any problems that you run into. So remember, derivative of a constant is 0. Derivative of x would be 1. And so we can actually add to that one a cx. So if you take the derivative of a constant of x, you end up with c. If we take the derivatives of a sum, you're allowed to take the derivatives of the two terms. And then our general power rule would be n, x to the n, and then we subtract 1. Our trig functions, sine was cosine, secant was secant x, tangent x, and tangent was secant squared x. And then cosine x, these were all negatives, all the cos. So this would be sine x, and then we just write what we have over here. So almost wrote tangent. Cotangent x, and then this one would be cosecant squared x. So now let's work in reverse. So we're going to be looking at the right side now and taking it back. That's what our integral or antiderivative does. So what was the one that gave us c? Right here. So that means this would be cx. It's just backwards. And we got to put plus c, but you can't use c. We got to pick a different letter here because we already used c for the constant. So we pick d for our next constant. Now if you had x, what was the one that gave us x? That's our general power rule. So if you had x, this would be x squared with a half. And then now we can put plus c because there isn't a c there. If you have the sums, you can take the integral of each one individually, like this. And our new general power rule for integrals is instead of subtracting 1, we add 1, and instead of multiplying it, we divide it. So you can see it's plus 1 and plus 1, and up here it's multiply and subtract. So now working in reverse, think about it this way. What was the trig function that gave us sine? That was cosine. So the antiderivative would be cosine of x. But remember, when you take the derivative of cosine, it's going to give you a negative. So what happens is now we have to put a negative next to all the ones that become cosine. So derivative of sine gave us cosine. Notice there's no negative, because if you take the derivative of sine, you get cosine. But if you take the derivative of cosine, you get negative. So we need to have that negative in there to cancel it. See, with antiderivatives, we're working backwards. So we're really trying to cancel a lot of this stuff. So what was it, the one that gave us secant squared? So going back up, secant squared was tangent. Oops. And secant tangent was secant. And cosecant, so it's a co, right? Cosecant was the one that gave us cosecant squared, was cotangent. But again, if you go back and look at your cotangent, cotangent gave us negative cosecant. So we have to have that negative. So the way I always remember it is when you take the integral, if you end with a co, you got to put a negative on there. So like this one, cosecant cotangent, we know is going to be cosecant x. That was the one up here that gave it to us. So cosecant cotangent was the derivative of cosecant. So cosecant is the antiderivative of cosecant cotangent, but there's a negative, so we need a negative to cancel it. So if you end with a co, put a negative in front of it. And there you have it. So these are your cheat sheets to go through each of the problems with. If you get stumped, look here. It'll give you the answer. Integrals on the bottom, derivatives on the top.